going on, guys? In this video we are going to see how to calculate the bias point of the circuit, and also we are going to draw the equivalent model. Now to find out the bias point of the circuit, first of all we have to find out IC. IC is collector current. To find that one out, I'm going to use the KCL. KCL will be, if I apply KCL for this one, this is going to be VCC minus VBE minus 0.5 voltage. Sorry, 0.5 voltage right here, and then the resistor in between is 12 kilo ohm, and also VBE plus 0.5 divided by the resistor in between, that is 13 kilo ohm, and that is equivalent to base current IB. And instead of base current, since we are interested in finding out collector current, base current is equivalent to collector current over beta. Okay, now here we are interested in finding out IC, so we can neglect this IB and equate this one directly to this equation. And to find IC, we just have to multiply everything by beta and get rid of this denominator. Okay, IC is going to be equivalent to beta times VCC. VCC is, we already have that one, so we can just keep it as it is. VBE, we don't have that, so there's another equation for VBE. VBE is equivalent to VT ln of IC over IS. Okay, this is the equivalent equation for the VBE. So instead of this one, we can replace VBE with this equation, because for this equation VT is a constant value. VT is always 26 millivolt, and IC is what we are trying to find. IS is provided right here, so if we put that one here, we can solve this one easily. Okay, so let's go ahead and put it right here. VT ln of IC over IS minus 0.5 divided by 12k ohm resistor minus here, instead of VBE, we can put VT ln of IC over IS plus 0.5 divided by the resistance in between, that is 13 kilo ohm, and that's it. And this one also should be multiplied by beta. Okay, now let's go ahead and replace the insert values for that. IC is equal to beta is 100 and VCC is 2.5 voltage. 2.5 minus VT is 26 millivoltage, milli ln of IC over IS is 5 times 10 to the power of minus 16. 5 times 10 to the power of minus 16 ampere minus 0.5 divided by 12k ohm resistance minus beta is 100 and VT is 26 millivoltage, and ln IC over IS is 5 times 10 to the power of minus 16. 5 times 10 to the power of minus 16 plus 0.5 divided by 13 kilo ohm resistor. And here if we solve for IC, that's equivalent to 1.01 milliampere. Okay, milliampere. And now we have solved for IC. Now the next thing is we are going to solve transconductance, that is GM. GM is equal to IC over VT. IC is 1.01 milliampere divided by VT, that is 26 millivoltage, that is equivalent to 38.8 millisiemens. And the next thing is we are going to find out the R phi. R phi is equivalent to beta over GM. Beta is 100 divided by the transconductance, that is 38.8 millisiemens. And if you divide that, you will get 2.57 kilo ohm resistance. And let's go ahead and draw the equivalent model. Equivalent model of this circuit. Okay, let's draw that one right here. And the resistance in between is the parallel resistance, 12 k ohm to 13 k ohm parallel, 12 k ohm parallel to 13 k ohm. And here we will have another resistance, that is R5 resistance, V5 voltage across that. And here we will have a dependent current source, that is here this arrow is downward, so that's why we have this one downward, and that is GMV5. And this 1 kilo ohm resistor will be right here, 1 k ohm, and this is the equivalent model circuit of this one. I hope you guys find this video helpful. Thanks for watching, and if you're trying to learn electronics, there are a bunch of videos in my playlist. I hope you guys watch that too, and don't forget to subscribe. See you next time.